Okay, so numbers 6 and 7. They're kind of similar. So they're having us look at different forms. And on A, we're going to figure out which is the biggest between 3/4, 34%, and 3.4. Okay. So the way to do these is to convert them all into one equivalent form. Okay, you can convert them all to a percent, you can convert them all to a decimal, or you can convert them all to fractions, and I'll do one of each as we work through these. So with this first one, I'm just going to convert them all to decimals, okay? So I know that 34% will be 0.34. Converting a percent to a decimal, I just divide by 100, or move my decimal 2 points to the left, or I just know that a percent is out of 100, so my last digit goes in the 100s place. So 0.34, that's in between 0 and 1. So I know that's going to be smaller than 3.4, which is bigger than 1. Okay, so now I need to convert 3/4 to a decimal. I want to get my numerator to 10 or 100 or 1000 to convert to a decimal. Quickest way to do that is just to know that 4 times 25 is 100. So 3 times 25 would tell me what the equivalent fraction out of 100 is, 75 hundredths. And I know I can write that as 0.75 because I put the 5 in the hundredths place of my decimal. So I have 0.75, which is bigger than 0.34, but both are smaller than 3.4, which is well over 1. So 3.4 was my biggest in A. Okay, on B, we have 1/4, 25%, or 0.25, repeating forever. So with these repeating decimals, I think the easiest way to do it is to convert them all to decimals. So 25% is 0.25. 1/4, I'm going to do the same thing I did in the last one. I'm going to figure out how to make the denominator 10 or 100 or 1000, whichever one is easiest. In this case, 100 is easiest. I multiply 4 times 25 to make it 100. And then I do the same to my numerator, times 25. So I'm going to have 25, because 1 times 25 is 25, out of 100. I'm going to write that as a decimal. Put my last digit of my numerator in the 100ths place, because it's out of 100. So it'd be 0.25. So 5 is in the hundreds place. So now I have two that are the same. So you could assume if two are the same that the third one will be the biggest one, unless there's a trick where I make them all the same size, which may or may not happen. But to figure out if this is bigger, I'm going to extend it out. 0.25 with a line over it is the same as 25, 25, 25, repeated forever. And I know that this is 252, whereas these are 250000000. So 25 with a 2 after it is going to be bigger than 25 with a 0 after it, which means that my repeating decimal is the biggest. Okay. So next I have 4/5, 75%, or 0.83. So this time I will convert them all into a fraction. Why not? So 0.83, 3 is in the hundreds place. So my denominator will be 100, be 83 out of 100. 75%, percent is always out of 100. It's going to be 75 out of 100, and I can already see which one's bigger here, 83. So now I need to convert 4/5 into 100ths, so I can easily compare them. So I know that 5 times 20 equals 100. It's my denominator. So I do the same thing to my numerator. 4 times 20 is 80. So now I have 80 100ths, 75 100ths, and 83 100ths, which tells me that 83 100ths This is the biggest number. So there's C. And now D, 2/3, 65%, and 0.7. So we'll convert all these to fractions just so that we've done it once. So 0.7 would be 7/10. 65% would be 65/100. And 2/3 would be, well, it's 2/3. So let's try and make our denominators equivalent so they're easy to compare. So the easiest one to do would be 7/10. I know that 10 times 10 is 100. And if I'm going to make my denominator 100 by multiplying 10 times 10, I got to multiply my numerator times 10. So I get 70/100. So we know which one is biggest there. Now, 2/3, remember from before, let's see a 3, a 9, or 11 in the denominator of my fraction. I'm going to get a repeating decimal. And those are going to, I want to have 9s in the denominator. So I could turn 2/3 into 3/9 like I did earlier. That doesn't help us compare. But what if we turn it into 99, which is really close, which makes it easy to compare? 2/3 times 33 equals 99. Okay. So I do the same to my numerator. 2 times 3 is 66. So I now have 66/99. Okay. Now, our denominators are not the same, but they're very close, which means that our numerators need to be extremely close for them to not be able to compare easily. And they're close, but not that close. I know that 70/100 is the biggest one, and it's going to be bigger than 66/99. So I know it's the biggest there. I could also think about it as 66/99 would be 0.66 repeated forever. And that's going to be smaller than 0.7. Okay, and last but not least, we're going to do something similar while we work through finding the equivalent numbers, okay? So A asks us to do 12/50, 25%, 0.24, and 1/4. Okay, so with these, forgive my ugly 4, we're going to want to try and turn them into some equivalent form to compare them. I think the easiest one here is fractions with 100 as our denominator. So 25%, that's just 25 out of 100. We know that because all percents are out of 100. 0.24, this guy is in my hundreds place. So I can write my decimal as a numerator out of 100. So I have 24/100, so those aren't equivalent. Let's do this with 50, 12/50. We need to make our denominator 100, multiplication or division. We all know that 50 times 2 is 100. So we do the same thing to our numerator. 12 times 2 is 24. All right, so now I have 2 equivalent ones. And we just need to figure out what 1/4 is out of 100 to see how it compares with the others. We remember from earlier that 4 times 25 is 100. So I do the same thing to my numerator. 1 times 25, 25/100. So now I have 25/100, 25/100, 24/100, and 24/100. Bingo, bango, bongo. Okay, that's A. We'll jump to B. 5%, 2/20, 1/2, 0.5. So let's do the same thing. Let's try and get these all out of 100. It's a nice, easy way to do it. So I know that 5% will be 5 out of 100 because every percent is out of 100. I know that 0.5 is 5 out of 10 because 5 is in the 10th place. So to get it to 100, I multiply my denominator, in this case, just times 10. 10 times 10 is 100. I do the same to my numerator, 50 out of 100. So those aren't equivalent. We have 50 out of 100 and 5 out of 100. We do that same process to our other 2 fractions. 2 out of 20. I remember from before that it's 20 times 5 to get to 100. So I'm going to do the same to my numerator. 2 times 5 is 10 out of 100. And all right, at this point, none of my numbers are equivalent. We're going to see if any are equivalent when we convert 1/2. So 2, how do I get from 2 to 100 with multiplication or division? 2 times 50 gets me to 100. So I do the same to my numerator. 1 times 50 is 50 out of 100. And I can now see that those two are equivalent. The other two are not. So I only have 2 equivalent numbers in this one, 1/2 and 0.5. C is 2/5, 40%, 0.4, 4/10. Okay, let's see what we can do with this one. So we have 4/10, and we see right next to it is 0.4. 4 is in the tenths place. So I would write that decimal as 4/10. So we already have 2 equivalent ones right there. I can look at 2/5, and I can know that to get 5 to 10, in this case, we'll just get it to 10 because we're trying to see if it's equivalent to 4/10. I just multiply 5 times 2 to get it to 10. And now I'll do the same to my numerator. 2 times 2 is 4, 4/10. Okay, so now I have 3 equivalents. Well, how can we check if 40% is equivalent to 4/10? Well, first we're going to write it as a fraction out of 100, which we can do with every percent, 40 out of 100. But now we're actually looking to turn our denominator of 100 into 10 to check if it's equivalent. So we're going to need to use division. We know that 100 divided by 10 is 10. So we need to do the same to our numerator. 40 divided by 10 is 4. I have 4/10 again. All 3 numbers were equivalent. And last but not least, coasting into the end of our study guide, 1/10, 1.0, 100%, and 5/50. Okay. So let's just try and convert them all to fractions, the numerator of 100. So 5/50, it's a nice, easy one to see. I know 50, I said numerator 100, denominator. I can see my denominator of 50. I just multiply that guy by 2 to get to 100. I do the same to my numerator. 5 times 2, 10 out of 100. Okay, we'll move down the line. 100%. We know a percent is always out of 100. In this case, it's 100 out of 100. Okay. Now, 1.0. Now, at some point, we'll just remember that 1.0 is 100%. Okay, as a decimal. But if we don't have that memorized yet, that's why we're learning this stuff. That's okay. We can look that our 0 is in our tenths place. So we can have a denominator of 10 and 0, but 0/10 isn't right. This number isn't 0. We have a 1 there. We actually have 10/10. We put the 0 from our tenths place in the numerator and then write the next number over. So we have 10/10 here. And if we want to convert that to 100, we multiply 10 times 10 to make our denominator 100. We do the same to our numerator. 10 times 10 is 100. And we see that we have 2 equivalents right there. Now we need to do our last number. We're going to make our denominator 100. You know that 10 times 10 is 100. So we do the same to our numerator. 1 times 10 is 10. And we see that we have those two are equivalent. So 1/10 and 5/50 were equivalent. 1.0 and 100% were equivalent. We have got to the end of our study guide.